Welcome to The Explainer. Today, we're going to pull back the curtain on the cloud. And we're not just looking at what it is, but the actual design philosophy behind it all. Its architectural blueprint.
So you've probably heard this phrase, right? The cloud is just someone else's computer. It's catchy, it's simple, but honestly, it really misses the bigger picture. The cloud isn't just a random pile of hardware somewhere. It's this incredibly deliberate, meticulously designed system.
A much better way to think about it is like a blueprint for a massive skyscraper. Before anyone even thinks about pouring concrete, an architect has to understand the building's purpose. And that's exactly where we're going to start, not with the tech, but with the why.
Okay, so what is the first absolute #1 rule of cloud architecture? It's simple. Technology serves the business, not the other way around. Every single technical decision, every piece of code is a direct answer to a business need. A cloud architect's job begins with questions like these. Are we trying to slash costs? Do we need to scale up like crazy to grab a new market? Are there specific legal rules we absolutely have to follow? These are the questions that guide every single choice they make down the line.
So this is the big question, right? How do you actually turn a business goal, like increase market share, into lines of code and spinning servers? How does a number on a spreadsheet become a real working piece of technology?
Well, this is where the magic really happens. You translate those business goals into what architects call quality attributes. Just think of them as technical promises. They're the measurable guarantees the system has to deliver on, like how fast it needs to be or just how rock solid its security has to be.
And these here are the core engineering principles of our whole blueprint. Things like availability, security, performance, they are all absolutely critical. But for the cloud, one of the most revolutionary, game-changing attributes is elasticity. That's the ability to grow and shrink your resources completely on demand.
Now, when a system needs to handle more and more users, you've basically got two choices. You can scale up, which means you build one giant, incredibly powerful machine, or you can scale out, where you just add lots of smaller, standard machines that all work together. The big problem with scaling up? It gets really expensive, fast, and even worse, it creates a single point of failure. If that one monster machine goes down, boom, everything stops.
And this idea, this scale-out philosophy, is the absolute bedrock of the cloud. Instead of betting everything on one giant, fragile machine, the entire system is designed as a massive fleet of interconnected computers. And that's what makes it more reliable, way more cost-effective, and just unbelievably flexible.
Okay, so we have our why, that's the business goals. And we've got our how, those are the design principles like scaling out. So now let's look at the what. These are the actual building blocks that you and I interact with. This is the famous as-a-service stack, or as you might see it, XaaS.
So at the very bottom level of our blueprint, we've got infrastructure as a service. The best way to think about this is like leasing a raw plot of land with all the utilities hooked up. The cloud provider gives you the fundamental computing, storage, and networking, but it's up to you to build everything on top of that.
Move up one layer and you get platform as a service. This is kind of like getting a pre-built workshop. The foundation's already poured, the power tools are all there, and developers can just show up and start creating their apps without having to worry about the underlying servers or operating systems at all.
And then right at the top, we have software as a service. This is the finished building. It's the ready-to-use application you just access through your web browser. We're talking about things like Gmail or Salesforce. You just use it. You don't manage a single thing behind the scenes.
So here's the crucial takeaway. As you move up that stack from IaaS to PaaS to SaaS, the responsibility for managing and securing the whole system actually shifts. With IaaS, you're responsible for a lot. With SaaS, the provider handles pretty much everything. And really, understanding this division of labor is absolutely key to using the cloud smartly and safely.
Look, this model wasn't just some small, incremental improvement. It was a fundamental paradigm shift. It completely changed the game from how information technology was built and managed for decades.
I mean, the shift is just dramatic. We went from these rigid, slow systems with specialized hardware to this whole new world of flexible, automated services. You know what the biggest change was? Instead of waiting weeks or months to order and install a new server, you can now launch one with a single click. And this wasn't just a technical change, it was a huge financial one too, turning massive upfront costs into predictable monthly bills. It also created entirely new ways of working, like DevOps, which brings development and operations teams together to run these super dynamic systems.
Now, the core idea that powers this entire model is something called service-oriented architecture, or SOA. It's actually a pretty simple but really profound concept. You break down big, complex systems into smaller, independent services that can all talk to each other. A database is a service. A login system is a service. And really, the cloud is just the ultimate expression of this idea at a massive scale.
And that brings us right back to where we started. See, cloud architecture isn't just a random collection of cool technologies. It's a powerful, deeply interconnected system that draws a straight line from a business goal to a quality principle to a concrete technical design. The why dictates the how, and the how defines the what. It's all connected.
So it kind of leaves us with one final question to chew on. Today's cloud was built to solve the big problems of cost, flexibility, and scale. But as the goals of business and even society continue to evolve, what problems will tomorrow's cloud be designed to solve?